Welcome. We'll be going through some exponent rules today on the Unit 11 study guide to help us make sure that we are nice and prepared and super confident for that upcoming summative. So, there's going to be a lot of different rules going on here. In some of these cases, you might be able to solve the problems or simplify them in different ways. Um, so just because the method that you used is not necessarily the same one that's shown on this video does not necessarily mean that you're wrong. You want to make sure that you have supporting work and that you can get your final answer to be a simplified match. In some of these, I might go through them a couple of different ways if there is another option that students might be prone to using. So when I look at question number one, I can see that we are multiplying. And so remember, when you multiply those bases, you are going to add the exponents. So the a to the third times a squared, we're going to add those exponents and make it an a to the 5. And b doesn't have an exponent on it, so that's an invisible 1. So b to the 1 times b to the 4, add those exponents again. 1 plus 4 makes it 5. That's all we can do to simplify it. Number 2, again, I am going to be multiplying the bases, and so I'm adding the exponents. And don't forget, these coefficients are treated just like they always have been. So that 6 coefficient times that 3 coefficient is an 18. Then when I start looking at my g's, I've got a g to the 8 and a g to the 2. Add those exponents, 8 plus 2, that makes it 10. And I'll take my h to the 7 and h to the 11, add those exponents, 7 plus 11 makes it 18. Here's our simplified answer, 18, g to the 10, h to the 18. Now, when you look at this number 3, I've got an exponent sitting on top of an exponent. So when you've got powers to powers, you are going to be multiplying. That 7 coefficient out front doesn't have anything going on with it right now. But this x to the 4 to the 3, we're going to do 4 times 3 and make it x to the 12. There's nothing else much going on here. You can rewrite that without the parentheses, 7x to the 12th. On that number 4, notice that the exponent 2 we have outside of the parentheses is working on multiple items of the base. There are multiple factors inside of those parentheses, and so we're going to have to utilize all of them. So the negative 3 that we have gets raised to the second power. That k squared we have gets raised to the second power. And the p to the 5 that we have will be raised to the second power. So negative 3 squared makes you think negative 3 times negative 3, that's a positive 9. And now this rule that we're going to use is the same as what we just did on that last one. When you've got your powers to powers, we're going to multiply. So k to the 2, multiply that 2 times 2, we're getting a 4. And for our p, I've got a 5 raised to the 2. 5 times 2 puts me at a new exponent of 10. There we are. In the second row of these problems, we're looking at, I've got another exponent outside of the parentheses, so I want to get that exponent 3 to spread through all of its base. I'll bring the 2y squared along. Nothing has happened with that yet, but it's got to be ready. And then for that other set of parentheses, I've got this negative 3 that's being raised to the third, and I've got this y to the fifth that's being raised to the third. So I want to go ahead and take care of these where my exponent is outside of the parentheses. So we're going to multiply, let's see now, this negative 3 to the third power. Well, negative 3 times negative 3 is positive 9, times another negative 3 is going to put us at negative 27. And then y to the fifth to the third, again, powers sitting on top of powers, we multiply those together. So this is now y to the 15. And so we simplify. Coefficients times coefficients, 2 times negative 27 is negative 54. And when we multiply our bases, we add our exponents. So y's times y, we're going to add the 2 plus the 15 and make it a 17 exponent there. We'll go look at this question number 6. So for some people, we'll do this question number 6 in 2 different ways. So the first option that I'm going to show you is if you notice that your exponent outside of the parentheses is a negative, and people don't necessarily like dealing with that negative exponent. So they want to take everything that the base is acting on and move it to the other side of the fraction bar with a positive exponent now. There's nothing in the numerator, so we hold that with a place value of 1. Now, this positive 2 exponent that we have outside the parentheses is going to have to spread the love and share with everybody. So we'll get that 4 squared we'll have this x to the fourth, that's squared, and we'll have this y to the negative third, b squared. So what does that look like as we're cleaning up? My one numerator stays the same. We can square that 4 in the denominator and get a 16. And now I see my x value has a power sitting on a power. Exponents that sit on top of exponents are going to multiply. So this is x to the 8. And again, with my y and power sitting on a power, we're going to multiply and get y to the negative 6. Also, I hope you notice, I hope you recognize, we do not leave negative exponents in our answer, so that will have to switch the side of the fraction bar. So y to the negative 6 starts in the denominator. It's going to relocate to the numerator, y to the positive 6 now for us. But that 16 as a coefficient is just fine and stays the same. X to the 8 is just fine and stays the same. Now, I did tell you we'd go ahead and work this one out two different ways. So let me get that problem rewritten here. And we'll take a look at it with another approach if that happened, if what I showed you there wasn't exactly what you were hoping for or didn't exactly make you feel comfortable. So you might also choose to use your exponent and spread it around so that it applies to every factor in there. So I can take that 4 and raise it to the negative 2. We can take that x to the 4 and raise it to the negative 2, and then also take that y to the negative 3 and raise it to the negative 2. So what does this mean? Well, 4 to the negative 2, I know that means I'm going to end up with a fraction, right? This is 1 over 4 squared because I don't want to have a negative exponent. We'll switch the side of the fraction bar. Right now it's over a 1, so that negative has to drop down into the denominator. And then we're multiplying here with an exponent sitting on an exponent, so that's going to give me an x to the negative 8th, and that's in my numerator. Uh, Also, then the y to the negative third to the negative 2. Negative 3 times negative 2 makes it a positive 6. So notice I've got a negative exponent here with my x. That's going to have to switch the side of the fraction bar. So y to the 6 is happy just where it is, stays in the numerator. That 4 squared in my denominator can clean up to a 16, and the x to the negative 8 that we had in the numerator, we're going to relocate that, become x to the positive 8. Either way you do it, you're going to get the same answer. So it is a personal preference about how you'd like to set that up. So as I look at number 7, similar idea as what we just had going on in number 6. You can start this one either way, whatever is going to help make you feel more comfortable or confident with this. I'm going to go ahead and start this with sharing that negative 2 so that it spreads to all of the terms, all of the factors that are within the parentheses. So my m to the 7 is being raised to the negative 2, and my n to the negative 3 is being raised to the negative 2. And in my denominator, that p to the 2 is being raised to the negative 2 power. So we have to multiply some of these out. That m now has a 7 exponent with a negative 2 exponent on it. That's going to give us a negative 14 power. The n has a negative 3 with a negative 2. Multiply those. That's now a positive 6. And in the denominator, p to the 2 to the negative 2, multiply there. 2 times negative 2 makes it p to the negative 4. Remember, we're not going to leave negative exponents in our answer. So I get my fraction bar ready. And this m to the negative 14, it's in the numerator, but we're not going to leave it. Switch it to the other side of the fraction bar. It's now m to the positive 14. N to the 6 has a positive exponent on it, so that's going to stay in the numerator just where it is. P to the negative 4, look at that negative exponent. We don't want to leave it. Move it to the other side of the fraction bar. So that means it's going to be coming up to the numerator for p to the positive 4. There we are. P to the positive 4, n to the 6 is all divided by m to the 14. So this number 8 then, as we get there, I've got this negative 3 exponent that we can see that's going to have to spread through all of the terms. So negative 2 is getting raised to the negative third power. N to the 2 gets raised to the negative third power. And m gets raised to the negative third power, while we bring all of that other parentheses along. 12m squared n is what we have. So work with all of these exponents. That negative 2 to the negative 3 power, well, that's going to let me set up a fraction bar with this because right now it's an over 1. Anything can be divided by 1. So I want to relocate that and put this negative 2 now to the positive 3 power for us. Everything else is going to stay in the numerator where it is. N to the 2 to the negative 3. Let's multiply those exponents together, make this an n to the negative 6. And my m to the invisible 1 is raised to that negative 3, so this makes it m to the negative 3. Still multiplying by this 12m squared n. And notice I wrote that so that it would be lined up on the numerator level. Everything that you had started on the numerator level. It was only after I started handling the negative exponents that I had to switch the side of my fraction bar. I'm going to go ahead and do some multiplication with this, right? Across my numerator, we're multiplying 12 times, I don't have any other coefficients, so we'll make that a 12. Then m to the negative 3 times m to the 2 makes it an m to the negative 1 because we added the exponents. And my n value, it's a negative 6 exponent and an invisible 1 exponent. So add those, multiply bases of n, add the exponents. Negative 6 plus 1 makes negative 5 over. And what do we have in that denominator there? Our negative 2 that was raised to the third power is going to give us a negative 8. So we're almost done, just a little bit more here. We've got to simplify the fraction. That 12 divided by negative 8, both of these can be divided by a 4. So you can get a 3 over negative 2. And also notice I've got negative exponents going on here. So a negative exponent in my numerator is going to switch to the denominator for a positive exponent. With my m to the 1, n to the negative exponent of 5, that's going to have to switch sides of the fraction bar to become a positive 5. And you can clean that up just one more bit because we don't need to show that invisible 1 exponent. So 3 over this negative 2m n to the 5. There were certainly other ways that you could have done that. Where I had gone ahead and done the multiplying across the numerators, you may have chosen to rewrite those negative exponents as well, and that would have worked also. So as we look at number 9, I see more negative exponents popping up here. And so I want to make sure that I handle so that my base is not going to have that negative exponent. So right now when I see it, that I have this negative exponent in my denominator, I'm going to switch the sides of the fraction bar, bring that whole base to the other side with now a positive 3 exponent. Is there anything left in the denominator now? Well, it's just a 1 placeholder. You don't even have to write that if you don't want to, because anything can be divided by 1. Now remember, every factor that's inside of that set of parentheses with the base is being raised to that third power. So we just need to know what 5 to the third is. That's 125, a to the third. When we go next door to number 10, I'm looking at this and I see any items with a negative exponent or ones that I want to focus in on. Make sure that I am going to get those to switch the side of the fraction bar. So p to the negative 6 is going to have to go to the denominator across the fraction bar to be p to the positive 6. I have an r to the fourth. That looks just fine in the numerator. We'll leave that with the positive 4 exponent in the numerator. I see that negative 12. And now notice this is a negative 12, but it's only a coefficient. So that rule about switching doesn't apply. It's still a negative number, stays exactly where it is. But your t to the negative 7, we don't want that negative exponent there. So we're going to relocate it, put it into the numerator with that positive. These are all different variables at this time, so I can't multiply or divide anything else there. So when I look at that number 11, again, there's a couple of different places that you might choose to start this. I think I'm going to go ahead and do a little bit of multiplication here. I'll multiply across the numerator 1 times that x to the sixth and m to the third. Well, 1 times anything is just itself, so that comes out nicely. When I multiply across the denominator, I see my x's times x's, and remember, when you multiply the bases, we add the exponents. So negative 2, excuse me, that's a positive 2 plus a negative 3, which is making this x to the negative 1, and m to the 8 doesn't have anything else to multiply with. Now I'm going to go ahead and get my division rule in place. So when I divide, I subtract my exponents, and that answer is always in the numerator of my fraction. So my division of x's is going to have me do 6 minus negative 1. 6 minus -1 would be 7. And then I'll do the same thing with my m's. Divide my m's and I subtract my exponents. 3 minus 8 puts us at -5. Now, there's nothing in the denominator at this point. It's a one placeholder, but I hope that you do recognize you have a negative exponent, so we need to rewrite that. M to the positive 5 now shows up in the denominator, while x to the 7 stays in the numerator. In that question number 12, I see an exponent 2 outside of my parentheses. We want that to act on everything in the base, so the 3 has to be squared, and the a to the third has to be squared. Divide this all by our 6a to the 14. And we keep going. 3 squared is a 9, and my a to the third to the 2. An exponent sitting on an exponent is going to tell us to multiply. 3 times 2 gives us 6, and my denominator has that 6a to the 14 staying the same. We're going to go ahead and simplify a little bit. My 9 and my 6 coefficients divide out a common factor there. These can both divide by 3. So I'm getting a 3 over 2 out of that. And with those a's, I'm dividing my a's, so I'm thinking about subtracting my exponents, right? Divide the bases, subtract the exponents. 6 minus 14 puts me at a -8. Remember, when you do that division and subtract the exponents, the answer is always in the numerator. But now I look and I see that it's a negative exponent. I am certainly not going to leave that negative exponent in the numerator. Switch it to the other side of the fraction bar, make it an a to the positive 8 there in our denominator. As we flip over to the back then, question number 13 here for us. We are looking at this -2 exponent that's outside of the parentheses. Make sure that that gets applied to everything within the parentheses. 3 to the -2. And x to the 2 is to the -2. And in my denominator, that y to the -3 is also raised to the -2. Well, let's do some simplifying here. So my 3 to the -2 is right now in the numerator. I'm going to move that to the denominator, make it a +2. And a power on a power, we're going to multiply that. So 2 times that -2 makes it a -4 exponent for us. And y to the -3 to the -2, again, an exponent sitting on an exponent is going to need us to multiply. So -3 times -2 makes +6. We're almost done with this one. Realize that you have a negative exponent showing up in that numerator. I don't want a negative exponent, so switch the side of the fraction bar, and that will be in my denominator now with a +4. The 3 squared in my denominator can be simplified as a 9. The y to the 6th didn't have any difficulties going on, leave it just as it is. And our numerator needs something, we'll give it a placeholder of 1. So, as we look at number 14, then, there's a couple ways that you might think about that. Some people might choose to multiply across the numerator and multiply across the denominator first with that. Some people may choose to try and start this out with some division. Either method is going to be okay and will get you to the right answer. It all depends on what you're comfortable with. I'll go ahead and perhaps I'll do this one both ways for us. So I'll multiply across the numerator first. 5 times 4 for my coefficients are 20. And the x to the 5 times x to the 3, multiply the bases, add the exponents. That's an x to the 8th. And then with my y's, y to the 7 times y to the 2, add those and get a y to the 9. In that denominator now, 3 times 3 is going to put us at a 9 coefficient. Y squared times y to the 8th, we're going to have to add those exponents. 2 plus 8 makes 10. And I have an x there in my denominator, nobody else to multiply with, so we'll bring it along. Now that I've multiplied that, I'm going to go ahead and I see that I've got the same variables in the numerator and the denominator, so we'll have to do a division problem. So checking out my coefficients, right? 20 divided by 9, that doesn't simplify. We'll leave that 29ths. X to the 8 divided by x to the invisible 1. So when you divide, subtract the exponents. 8 minus 1 makes that x to the 7. Remember, a division problem where you subtract the exponents always has its answer in the numerator. Now for my y's, y to the 9th is divided by y to the 10. Subtract my exponents. 9 minus 10, the answer is always in the numerator. That's a -1. We're not going to leave a negative exponent in our answer. So everything that has a positive exponent stays exactly where it is. Only this y to the negative 1 is going to relocate y to the positive 1 in my denominator, and you don't even have to write that positive 1 because it's the invisible exponent. But I did say that we'd do this one a second way, just to make sure that you see all the possibilities of it. Some people might start out with this trying to simplify and divide within those fractions as they have them. So on my first fraction there, the coefficients of 5 and 3 will not simplify. My x to the 5 doesn't have anything to combine with, so we'll leave that. But then y to the 7 divided by y to the 2, when you divide, you subtract those exponents and get a y to the 5 times what's happened in this second fraction. Now with my coefficients again, 4 divided by 3, that's not going to simplify. We'll keep it just as it is. X to the third divided by x to the invisible 1. So when you divide your bases, subtract your exponents, you are getting x squared. And y to the second divided by y to the 8. When you divide, subtract the exponents. 2 minus 8 gives us negative 6. So with that, now we could, if you wanted to, you've got another option. Do you want to multiply your variables and your bases together? Or do you want to handle that negative exponent? Either one is going to be okay. I think I'm going to go ahead and multiply here. So the 5 times 4 for coefficients gives me 20. X to the fifth times x to the second says that we add the exponents when we multiply. So that's an x to the 7. My y to the 5 times my y to the negative 6. Add those exponents. 5 plus negative 6 puts me at a y to the negative 1. And in that denominator, I've got a 3 times a 3. That's a 9. Notice I've got a negative exponent. We don't want to leave that. So 20x to the 7th stays right where it is. 9 stays right where it is, but the y to the negative 1, that negative exponent needs to switch to the other side of the fraction bar. So it's now a positive 1 exponent on the y in that denominator. Notice this is the same answer that we just got. Either choice is fine. In this number 15, it's all a division problem here for us. So the negative 25 divided by 5 makes negative 5. And x to the 9 divided by x to the 3, when you divide, subtract those exponents. 9 minus 3 makes x to the 6th. That answer is always in the numerator. And y to the 3 divided by y to the 4, subtract those exponents in a division problem. 3 minus 4 makes negative 1. We don't want to leave a negative exponent in our answer. So that one placeholder that we have in the denominator, because nothing landed there, well, we keep the negative 5. It's a coefficient, so it stays right where it is. X to the 6th already has a positive exponent, stays where it is. Y to the negative 1, we're going to drop that down below with a positive 1 exponent now. It switched sides of the fraction bar. And that invisible 1 exponent, well, you don't even have to write it because it is invisible. On that 16, again, you may choose to start off with some division or you may choose to start off with some multiplication because these sets of parentheses are just on their own. There's no exponent outside of the parentheses saying that you have to work and manage that first. So if I go ahead and multiply, 12 times 2 for the coefficients makes 24. A to the 4th times a to the invisible 1, add those exponents, 4 plus 1 makes this a to the 5. B to the 3 times b to the 7. Add those exponents and I'm getting b to the 10. C to the negative 5 times c to the 2. Add those exponents. This is a c to the negative 3. And my denominator is going to stay the same right now. 32, a to the 7, b to the negative 2, and c. Now it's a division problem for me to focus on because I have just one example of, or just one variable of each type. So the 24 divided by the 32, you can simplify that, dividing each of these by an 8. And so I'm looking at 4, or excuse me, no, I'm looking at 3 over 4. I got ahead of myself there. And now with my a's, a to the 5 and a to the 7. When you divide your bases, subtract the exponents. 5 minus 7 makes negative 2. That answer always goes in the numerator. For my b's, b to the 10 and b to the negative 2, when I divide my bases, subtract my exponents. 10 minus negative 2 makes me think 10 plus 2. That's going to be an exponent of 12. The answer always goes in the numerator. And c to the negative 3 divided by c to the invisible 1. So -3 minus 1, as I subtract the exponents, that's going to be c to the -4. Answer always goes in the numerator. Notice, do you see those negative exponents? We got to clean those up so the coefficients stay just where they are. And b to the 12 already has a positive exponent, stays just where it is. A to the -2 needs to switch to the other side of the fraction bar. C to the -4 needs to switch to the other side of the fraction bar. So we get 3b to the 12th over 4a squared, c to the 4th. Just a few more questions for us to practice with and make sure that we are excellent with our exponents. In this number 17, I notice something very special. I notice a set of parentheses that's raised to the 0 power, and anything that is raised to the 0 power is 1. So even though it's there and looks a little complicated, you end up not having to do too much with it. That entire space is like we're multiplying by a 1. Meanwhile, this 2 exponent is also going to have to spread the love and be used with every factor inside those parentheses. So the 3 is squared, as well as the v to the third is squared. Notice there's also this squared in my denominator. That's going to have to spread through and apply to all of the factors in that set of parentheses. So the 6 is squared, the p to the third is squared, and the v to the 7 is squared. We're going to clean these up now. So that 3 squared gives me 9. V to the 3 to the 2. An exponent sitting on an exponent tells me to multiply. That's a v to the 6. Multiplying by 1, that doesn't do anything. I don't have to worry. In that denominator, 6 squared gives us a 36. P to the 3 raised to the 2. 3 times 2 puts us at a 6th power. And v to the 7 to the 2, we're going to multiply those. 7 times 2 for a 14. We got a little bit of division that can happen. My 9 and my 36 coefficients, those can both be divided by 9. So take out a 9 factor, I got 1. Take out a 9 factor, and I got 4. And I noticed that my v's can be divided with each other. Subtract those exponents. 6 minus 14. Answer always goes in the numerator. It's a -8. P to the 6 stays in the denominator. It doesn't have anything going on. We're not going to leave our answer right here. No way. We got a negative exponent to handle. So the 1 and the 4 and the p to the 6 are just perfect where they are. It's the v to the -8 that needs to swap sides of the fraction bar, become a v to the +8 when it drops to the denominator. In 18, we're going to have to take these exponents that are outside of the parentheses and spread them through so that each factor gets some. 4 gets the 3rd power. F to the -2 gets the 3rd power. R h to the 0 gets the 3rd power, and j to the 4th gets the 3rd power in the numerator. In the denominator, 8 gets the 2nd power, f to the 3rd gets the 2nd power, h to the 4th gets the 2nd power, and j gets the 2nd power. So to clean these up a little bit and simplify the number of parentheses that we've got, 4 to the 3rd power is going to be nicely rewritten as 64. Then anytime you have an exponent sitting on an exponent, make sure you multiply. So you're doing an f to the -6. We're doing an h to the 0 when we multiply, and then a j to the 12 as we multiply that 4 times 3. The denominator has an 8 squared, which is 64. My f is going to do the 3 times the 2 for a 6. H is going to multiply 4 times 2 on those exponents for an 8. And j to the invisible 1 multiplies by 2, and that gives us j squared. So a division problem for us now. Looking at the coefficients, 64 divided by 64 divides itself out. We don't have to worry about that now. And so when I divide, I'm going to subtract my exponents. Answer always goes in the numerator. F to the -6 divided by f to the 6. -6 minus 6 puts us at f to the -12. H to the 0 and h to the 8. 0 minus 8 gives us h to the -8. Answer always goes in the numerator there. And j to the 12 divided by j squared. You're doing 12 minus 2 for the exponents. That's j to the 10. There's nothing in the denominator now except for that one placeholder. All you've got to do is rewrite with your negative exponents. So I see j to the positive 10 is my positive exponent to stay in the numerator. I notice that my f is going to have to change sides of the fraction bar, and I notice that my h is going to have to change sides of the fraction bar so that we can simplify. Lastly, here on that 19, we are going to have to work with these exponents that are outside of the parentheses, spread them through so that all the factors get a turn. So 3 gets squared, x to the 6th gets squared, and y to the 3rd gets squared. This is divided by our y squared times. Then we've got 4y squared in the numerator. And my 5 in that denominator stays as it is, but then the 3 gets cubed, and the x to the 4th gets cubed, and the y gets cubed. So I'll clean those up. 3 squared is a 9. Multiply powers on powers. This is x to the 12th. Multiply powers on powers. That's y to the 6th, still over y squared, times. And on my other fraction, I've got 5 times 3 to the 3rd, which is 27, x to the 4th to the 3rd, multiply powers on powers, that's x to the 12, and then y to the 1 to the 3, multiply 1 times 3 and get y to the 3rd. So I'm going to keep on going and do some multiplication with this. So coefficients, 4 times 9 are going to be 36. X to the 12 doesn't have anything to multiply with. And then my y to the 6 times y to the 2nd, add those exponents when we multiply, that's a y to the 8. In that denominator then, we're doing a 5 times a 27. This is 135 for us with a coefficient. A y to the 2nd times a y to the 3rd, add the exponents, this is y to the 5. There's an x to the 12, and that doesn't have anything else to multiply with. So I'm going to think about dividing. I'm going to look at that 36 and that 135, see if they have any common factors that we can divide out of them. And yes, they can both be divided by a 9. So you're looking at 4 over 15. And I'm going to start dividing. X to the 12 divided by x to the 12. Well, you're thinking 12 minus 12 on those exponents is a 0, right? Anything divided by itself cancels out. And then when I look at the y's, y to the 8 divided by y to the 5, subtract x or subtract 8 minus 5. Answer always goes in the numerator. That's a y to the 3. Well, look at that. You're done. I hope you feel super confident and that you're going to do awesome on this exponents test. Have a wonderful day.